Hello everyone, thank you for joining us today on our presentation on Unlock Significant Archer ROI through a Layered Security Approach. I'm Leena Bongale, Manager of Data Analytics and Governance at TD Bank. I will speak a little bit about my background in a second, but first I would like to thank RSA for giving us this opportunity 2 times in a row. At last year's Virtual Archer Summit, we had presented on Data Gateway, which is a great new, well, not so new feature now of Archer. It's an absolute pleasure, not only because we are able to present this year as well, but to have you all attending this session interested in knowing more about further securing your Archer platform, as it is a critical element in a successful implementation of Archer from a security and a high availability perspective of your organization. I'm a manager of data analytics and governance at TD Bank. My title actually suggests that I don't do anything related to IT security, but I am an IT risk and security practitioner. My background is in IT and currently I'm involved in data security and governance. I got into IT risk and security management about a decade ago when I started working on Archer. I could say Archer helped me find my passion and second career in the IT risk and security management space. Recently, I got my CRIS certification, so that and my decade-long experience in working with Archer in different financial institutions is where a lot of today's presentation material is coming from. This is what I like doing. Speaking about, more like preaching about IT security and risk management at various webinars where I get invited as a speaker. So with that, I will hand it over to Pankul for her self-introduction.
Wow, what an amazing conference till now, isn't it? I'm sure you must have gained new insights regarding Archer. I myself have taken a bunch of notes and I'm going to implement new ideas in my future Archer experience. So about me, I am Pankaj Chitrav and I've been working in TD Bank for more than past 2 years. And Microsoft and myself were introduced to each other way more 14 years ago, and we have been holding each other's hand till now. My expertise lies in automating things and making a process easy so that it can reduce cost, resource, and time of an organization. I am very passionate about agile way of working and I'm agile certified practitioner. From last 2 years, I've been working in Archer platform and it includes migrating Archer from 6.2 to 6.7 and creating new instances of 6.8 for our new EGRC project. And in those also, I was able to do the automations while installing and was involved in technical architect frame. I hope you will like our presentation and this will add value to you and your organization.
Thanks, Pankaj. Before we get into the meat of the presentation, I will walk you through the agenda. In today's agenda, we begin first by taking a look at what is a layered security. We'll look at what is a layered security in the context of Archer platform. Then we'll see why it is important for the Archer platform. We'll talk about how a layered security approach could be slightly different than the norm of how organizations set up their Archer platform, and how a layered security is an enabler for businesses to carry out their tasks effectively. Then we'll proceed to dissect the Archer architecture. This we'll do to take a pragmatic, security-driven approach to setting up the Archer platform. We'll go through the practical methods of implementing layered security. Our goal is to share our experiences and show you at a high level the various layers of security you can implement for your Archer platform. We'll also share a few tips of how to maintain a good cyber hygiene. And then last but not the least, we would certainly like you to ask us questions that you may have as to how you can implement this in your organization as we wrap up. So the big question is, how many of you trust that the data in your Archer applications is absolutely secure? The key word here is absolutely. For those that thought, yes, absolutely, my Archer platform is 100% secure, then I would say, let's just take a look at this. There are two types of organizations. Those who have suffered a cyber attack and those who don't know they have. So now let's answer the question again. How many of us absolutely trust that the data in our Archer applications is 100% secure? Cool. But you know what? Attending our 45-minute presentation on taking a layered security approach to securing your Archer applications is still not going to give you 100% confidence in securing your data in your Archer applications. But what our presentation will do for sure is help you sleep better at nights, knowing you can secure your Archer platform at multiple levels and the resources that are available to you. The reason today you, nor anybody in the IT world, can trust their web application to be 100% secure is because a web application, regardless of whether a homegrown tool or a vendor tool like Archer, sits in an organization's network, and gone are the days when a network could be trusted. Today, everything in your network has to be protected. Your Archer platform typically contains information worth millions and even billions of dollars about threat risk assessments, vulnerability scans, or maybe vendor or third-party risk, or maybe you store business resiliency plans. All this is invaluable data for your business's day-to-day operations and at the heart of the GRC management. As Archer admins, developers, and even GRC strategy leaders, you spend a significant amount of your day in safeguarding your Archer data from corruption, compromise, or loss. The importance of protecting this data increases as the amount of data created and stored in Archer continues to grow at unprecedented rates. There is also little to no tolerance for downtime that can make it impossible to access important information. So, you're always on the lookout of a data protection strategy to ensure that your Archer data can be restored quickly after any disruption or loss. If you're thinking that your Archer system has operated securely for many years, and there is no reason to believe that it is now suddenly the target of an attack, then I would say think again, because there is no guarantee that it will continue to be so. The reason I say that is because the great pandemic caused millions of employees to work from home, resulting in the need for remote data protection. Archer admins are also seeing more network traffic at irregular hours. Working hours are no longer 9 to 5 as remote work is often disrupted by sporadic household tasks throughout the day, inevitably shifting the workday into early morning or late night. Not only is the pandemic driving a need for greater application security, but also a high demand for availability. An organization's security posture has never been more critical, especially now that the global workforce is logging on remotely. While security fundamentals haven't changed, the attack surface has massively expanded. The rapidly changing threat landscape is driving business decisions around need for improved security, reliability, and scalability.
The only way forward is for organizations to adapt to ensure they're protecting their Archer data wherever their employees are, whether they're working in the office or whether they're working from home.
Now, I probably got you wondering, and understandably so, isn't it RSA's responsibility to make a foolproof, secure Archer architecture? After all, it's a vendor COTS tool. The answer is yes and no. Yes, because Archer being an RSA product, and RSA is a leader in providing integrated risk management solutions that enable customers to improve strategic decision making and operational resiliency. The tool architecture does a great job in securing your data in it. So why the no pat in the answer? There's no doubt that Archer has the potential to be more secure than GRC solutions developed in-house. The keyword here is potential. Just because Archer can be more secure doesn't mean businesses always enjoy greater protection when they set up Archer platforms. This has less to do with Archer and more to do with how businesses and organizations approach security, management, and oversight. In other words, it's the network perimeter around Archer platform that matters. The tool itself won't insulate you from the dangers that exist in the cyber landscape. It's really no different than the cloud security shared responsibility model. Cloud service providers adhere to a shared security responsibility, which means your security team maintains some responsibility for security as you move applications, data, containers, and workloads to the cloud, while the provider takes some responsibility, but not all of it. Your organization owns the security for things like data classification, network controls, and physical security. The division of these responsibilities is what I refer to as the shared responsibility model between your organization and RSA. According to Gartner, over the next 3 years, at least 95% of COD security failures will be the customer's faults. Hopefully, a suggested security architecture and best practices can help your organizations avoid becoming one of those statistics. Keeping your businesses protected against cyber attacks is a challenge, but you can alleviate a lot of risk if you adopt a layered security approach. Layered security refers to security systems that use multiple components to protect operations on multiple levels or layers. This term can also be related to the term defense in depth, which is based on a slightly different idea where multiple strategies and resources are used to slow, block, or delay or hinder a threat until it can be completely neutralized. The layered security concept creates an interwoven network of protection that prevents unwanted intruders from accessing or even lingering for longer periods of time within your system. If you need a cybersecurity program that is both effective and efficient, go for the layered approach. It provides multiple levels of defense that both identifies and eliminates threats on many different levels. With each added layer, you compound your level of protection until you have a wall of security that is almost impenetrable. The increased risk of loss associated with cyber attacks cannot be denied. So it's vital that you use a security approach that takes many different types of threats into consideration and deals with each one quickly and efficiently. Okay, so now let's look at the canvas before we start painting the layered security painting. The core architecture of an on-prem Archer application is divided in the following logical tiers. The interface tier is a collection of ASP.NET pages written in C#. The pages separate the presentation logic from business logic through the use of code behind files. The pages invoke the application tier to retrieve and manipulate data. The application tier, this is a collection of C# objects that encapsulates the business logic of the application. These objects communicate with the database via a common database object which encapsulates the stored procedure calls. The application tier is not allowed to make direct dynamic statement SQL statements. Instead, all data is achieved through RSA Archer stored procedures. And then the database tier, this is a collection of the stored procedures that act upon the underlying data model of the GRC platform. We know that the core Archer architecture has at least 3 machines, let's call them servers, that communicate with each other over the network. So we have the web tier, the integration of the services tier, and the database tier, all on your network and communicating with each other. And then we have the main actor, the user, that is accessing the web application by sending a request to the web server over the network. Typically, all requests from the user's browsers go directly to your Archer web server, and the web server sends responses directly to the client. Now, in this infrastructure diagram, let's add a reverse proxy component between the client's browser and the web server. So now all requests from the end user's browser will go directly to the reverse proxy server, and the reverse proxy server will send its requests to and receive responses from the web server. The reverse proxy will then pass along the appropriate responses to the end user. So now the sequence of activities will be: when an end user clicks on the Archer website URL, the request is first forwarded to the DNS resolver, who then sends the request to the reverse proxy server. The reverse proxy server passes the request to the Archer web server. And the same sequence happens in reverse for process requests coming back from the web server to the end user's browser. It is also possible to use a reverse proxy as an efficient HTTP load balancer to distribute traffic to several application web servers and to improve performance, scalability, and reliability of your Archer web application. The load balancing feature distributes traffic across several web servers by using the TCP/IP networking protocol. The combined features of reverse proxy and load balancer provides reliability and performance for your Archer web servers. Reverse proxy servers and load balancers are components in a client-server computing architecture. Both act as intermediaries in the communication between the client and servers, performing functions that improve efficiency. Just by adding one reverse proxy layer, you can now add more than one web server for your Archer platform. Deploying multiple web servers also eliminates a single point of failure, making your Archer website more reliable. Most commonly, the servers all host the same content, and the load balancer's job is to distribute that workload in a way that makes the best use of each web server's capacity, prevents overload on any one web server, and results in the fastest possible response to the client. Whereas deploying a load balancer makes sense only when you have multiple web servers, it often makes sense to deploy a reverse proxy even with just one web server or application server. You can think of the reverse proxy as your Archer website's public face. Its address is the one you will publish for your Archer website, and it sits at the edge of the site's network to accept requests from all web browsers and mobile apps for the content hosted at the Archer website. The benefits are twofold. First, you get increased security. No information about your backend servers is visible outside your internal network, so malicious clients cannot access them directly to exploit any vulnerabilities. Many reverse proxy servers include features that help protect backend servers from distributed denial of service attacks, that's your DDoS attacks, for example by rejecting traffic from particular client IP addresses, that is by blacklisting them, or limiting the number of connections accepted from each client. The second benefit is of increased scalability and flexibility. Because client can only see the reverse proxy's IP address, you are free to change the configuration of your backend infrastructure. This is particularly useful in a load balance environment where you can scale the number of servers up and down to match fluctuations in traffic volume. Agree that adding a reverse proxy will add to your infrastructure and administrative costs, but the benefits you achieve by adding a reverse proxy will give you a much higher return on investment. First and foremost, it gives you protection from attacks. With the reverse proxy in place, your Archer website never really needs to reveal the IP address of your web servers. This makes it much harder for attackers to leverage a targeted attack against your Archer website, such as a DDoS attack. Instead, the attackers will only be able to target the reverse proxy, which provides tighter security and more resources to fend off a cyber attack. Reverse proxies can cloak the IP address and other characteristics of origin servers. Thus, your website's origin server can maintain its anonymity better, increasing its security significantly. Since the reverse proxy will receive all the traffic before it reaches the web server, any attackers or hackers would find it harder to target your website with security threats, you guessed it right, such as a DDoS attack. You can use a strict firewall to harden the reverse proxy with tighter security against common cyber attacks. Without a reverse proxy installed, it is difficult to remove malware or start takedowns. The next benefit you get by adding a reverse proxy is that it can also cache content, resulting in faster performance. For example, let's say you have a user in Australia who visits a reverse proxied website with Archer web servers in Florida. The user might actually connect to a local reverse proxy server in Australia, which will then have to communicate with an origin server in Florida. The proxy server can then cache or temporarily save the response data. Subsequently, your Australian users who browse the site will then get the locally cached version from the Australian reverse proxy server, resulting in much faster performance. Since the reverse proxy is closer to the user than the origin server, the website will take less time to load, making it perform superbly. Basically, you can use a reverse proxy for web acceleration purposes by caching both static and dynamic content. This can reduce the load on the origin server, resulting in a faster website. Next, you get superior compression. Server responses use up a lot of bandwidth. Compressing server responses before sending them to the client can reduce the amount of bandwidth required, speeding up server responses over the network. A reverse proxy is ideal to compress server responses as it sits in between the web server and the client. We also can get SSL encryption. Encryption and decryption SSL or TLS, which is the newer version of SSL communications, for each client can be computationally expensive for your Archer web server. A reverse proxy can be configured to decrypt all incoming requests and encrypt all outgoing responses, freeing up valuable resources on the web server. Encrypting and decrypting SSL TLS requests for each client can be highly taxing for the web server. A reverse proxy can take up this task to free up the web server's resources for other important tasks like serving content. Another advantage of offloading SSL or TLS encryption and decryption is to reduce latency for clients that are geographically distant from the origin server. You can also opt for a reverse proxy with specialized SSL TLS acceleration hardware to optimize this task even further. Such a reverse proxy is called an SSL TLS termination proxy. Then we have the most popular benefit, that's the load balancing. Since Archer is a popular website in most organizations, it gets thousands of internal users every day and it may not be able to handle all its incoming site traffic with a single web server. Instead, the site can be distributed among a pool of different web servers, all handling requests for your Archer website. So by adding a reverse proxy, it provides a load balancing solution which will distribute the incoming traffic evenly among the different web servers to prevent any single server from becoming overloaded. In the event that a server fails completely, other servers can step up to handle the traffic. A single web server cannot handle all the incoming traffic to your very popular Archer website from hundreds and thousands of users daily. In this case, you can distribute the traffic smartly among a pool of many Archer web servers. Usually, all the servers will host the same content to eliminate a single point of failure, making the website more reliable. A reverse proxy is a great way to set this up as it can receive the incoming traffic before it reaches the web server. If a web server is overloaded or fails completely, it can distribute the traffic to other web servers without affecting the site's functionality. The reverse proxy can then gather responses from all the servers and deliver them to the client. Since we use most of the popular reverse proxies primarily for load balancing, they are also referred to as load balancers. And then last but not the least, you can also do monitoring and logging of traffic. A reverse proxy captures any requests that go through it. Hence, you can use them as a central hub to monitor and log traffic. Even if you have multiple web servers to host all your website's components, using a reverse proxy will make it easier to monitor all the incoming and outgoing data from your Archer website. Some might even say that the global load balancer and the local reverse proxy resemble a relay race team in the Olympics. What? You thought there would be no references to the Olympics? Going back to our layered security architecture diagram, let's say we add yet another server called a global server load balancer in between the end user's browser and the reverse proxy. Why would we do that? A global server load balancer is an advanced load balancing method for distributing website traffic among many servers placed strategically around the world. It's typically done via anycast routing technique where the reverse proxy picks up the server node based on the fastest travel time between the client and the server. So in this scenario, either you could have your Archer web servers in many parts of the world, or another way you could leverage a global server load balancer is to direct traffic between your production and DR sites. Pankaj will be covering the setting up of production and DR sites a bit later, so I won't go into depth here, but in the concept of significance of adding a global server load balancer, the global server load balancer will direct traffic either to the production web servers or for any reason if your production site is down, then all users will be directed to the DR site. Typically, your production and DR servers will be located in different geographic regions. Hence, not only does the global server load balancer increase the site's reliability and security considerably, it also reduces latency and load times, thereby enhancing your user experience.
Thanks, Lena. Wow, it's really exciting to be here and sharing with you regarding the security layered approach and how we can leverage it while installing Archer. I will start with the disclaimer first. Well, I know it should be the last part, but I'm including it so that there is no confusion while going through this presentation. Every organization has their own needs for using Archer. In few organizations, Archer may be used by restricted employees or executives for reports, and they may not need so many security layers. And in some organizations, users may be more, but the data is not so sensitive or confidential, like customer support system or any supporting system and taking care or tracking the tickets. And in some organization, the users can be more and the data must be secured and is sensitive. In those cases, yes, security layered is needed while installing Archer. So depending upon your organization's need, you may choose where and which security layer you should use or which can be just avoided. It's up to you. Okay, so let's begin with. Here we will look to the objectives of the network security zones, need of network security zones in today's world. How does it help us to secure our network application and data? Types of security zones. Why should we use security zoning for Archer? Throughout the presentation, I will keep on including Archer concepts with the security zone and why is it necessary to have security zoning when installing Archer. I will try to relate it as much as possible and as much as I have an experience in. The main objectives of security zones are to protect the network, detect intruders, contain attacks, and prevent this interference from reaching the internal network. A network can have multiple security zones with several layers of security in each zone. Even with security zone in place on the network, each zone must still be able to maintain a level of communication. The systems and components on a network, regardless of the security zone they fall under, still share resources on the network, such as system logging, system audits, and access controls. In today's world, network attack happens every second and it is important for organizations to ensure that they have security features in place on their networks that will help reduce their risk of these types of attack. One way to mitigate this is by creating security zones. A security zone is a segmented section of a network that contains system and components with limited access to the internal network. These are logical systems grouping based on common functions, example database, middleware or front-end, and common network security controls, example firewall, IPS within the security levels. The security levels are dependent on the data that needs to be protected. Critical data will have the highest level of security features with the most restrictions. Within each security zone, there is a layer of trust or a trust zone that allows for the sharing of resource and communication between a higher level security zone and a lower level security zone. Take for example, a web server that must be able to communicate with the application servers in order to ensure that data is published for user. In turn, the application server must be able to communicate with the database server in order to retrieve the necessary data. Even though each server is in different security zone with different levels of security features, there is a trust zone in place that allows for the shared resource between each server. So, before implementing security zones, you have to identify what you want to protect on your network. From there, you can start establishing the different security zones. Let's discuss some of the security zones that can be established. First is the uncontrolled zone. It is also known as black zone or red zone. Typically, it represents the public domain such as the global internet that is outside the boundaries of your organization. It cannot be controlled by an internal organization, and so this zone is deemed as untrusted and most vulnerable to security breaches. Web servers are placed in red zone. Hold on, you must be thinking, oh, web server? She has done it wrong. She is showing it in yellow. Well, herein comes the Archer. So in Archer, web servers also need to connect with database and bring data. So web and app server both are connected to the database server. And to save and to secure web servers for Archer, we place Archer web servers on protected zone. Therefore, you can see here the web servers are placed in a yellow zone, which is also known as protected zone and which is our next zone, known as controlled zone. The controlled zone might be an organization's intranet network or a demilitarized zone, DMZ. The Internet DMZ is an internet-facing controlled zone that contains components with which clients may directly communicate. You may think it as a buffer between the uncontrolled internet and your internal networks. This zone is typically bounded by firewalls, which enables you to control incoming traffic from the internet to the host, outgoing traffic from host to the internet, incoming traffic from internal network to host, and outgoing traffic from host to the internal networks. You can use access management system to control access to the web server, or you can increase data security using reverse proxy servers. Each reverse proxy server can connect across a firewall to the web server, which resides in the most restricted intranet zone. Then comes third, it is a restricted zone or a secured security layer. The restricted zone is a highly controlled zone that must not have any type of access to an untrusted zone. This zone can have mission critical data and systems operating on it. This zone will have the highest level of security features and strict firewall rules in place to control all incoming and outgoing traffic. A restricted zone supports functions to which access must be strictly controlled. Direct access from an uncontrolled network should not be permitted. In a large enterprise, several network zones might be designated as restricted. A restricted zone is typically bounded by one or more firewalls that filtered incoming and outgoing traffic. Database servers typically are placed here. When establishing security zone on a network, there are several factors that should be considered. These factors include identifying requirements, mapping communication patterns, creating an IP address schema for the enterprise, identifying network segmentations, identifying control points, and implementing access control. Here we will see what is a firewall, how does firewall work, and types of firewall. A firewall is a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block specific traffic based on a defined set of security rules. Firewalls have been a first line of defense in network security for over 25 years. They establish a barrier between secured and controlled internal networks that can be trusted and untrusted outside networks such as internet. A firewall can be a hardware, software, or both. Firewalls carefully analyze incoming traffic based on pre-established rules and filter traffic coming from unsecured or suspicious sources to prevent attacks. Firewalls guard traffic at a computer's entry point called ports, which is where information is exchanged with external devices. For example, source address 172.10.1.2 is allowed to reach destination 172.18.2.1 over the port 25. Think of IP address as house and port numbers as room within the house. Only trusted people are allowed to enter the house at all. Then it's further filtered so that people within the house are only allowed to access certain rooms, which can be said destination ports, depending on if they are owner, a child, or a guest. The owner is allowed to any room, that is any port, while children and guests are allowed into a certain set of rooms. Those can be specific ports. As mentioned earlier, firewalls can either be software or hardware, though it's best to have both. A software firewall is a program installed on each computer and regulates traffic through port numbers and applications, while a physical firewall is a piece of equipment installed between your network and gateway. Packet filtering firewalls are the most common type of firewalls. They examine packets and prohibit them from passing through if they don't match an established security rule set. This type of firewall checks the packet source and destination IP addresses. If packets match those of an allowed rule on the firewall, then it is trusted to enter the network. While packet filtering firewalls can be effective, they ultimately provide very basic protection and can be very limited. For example, they can't determine if the contents of the request that's been sent will adversely affect the application it's reaching. If a malicious request that was allowed from a trusted source address would result in, say, the deletion of a database, the firewall would have no way of knowing that. Next generation firewalls and proxy firewalls are more equipped to detect such threats. Next generation firewalls combine traditional firewall technology with additional functionality such as encrypted traffic inspection, intrusion prevention system, antivirus, and more. Proxy firewalls filter network traffic at the application level. Unlike basic firewalls, the proxy acts an intermediary between two end systems. The client must send a request to the firewall where it is then evaluated against a set of security rules and then permitted or blocked. Most notably, proxy firewall monitor traffic for layer 7 protocols such as HTTP and FTP and use both stateful and deep packet inspections to detect malicious traffic. Other known firewall types are network address translation and stateful multilayer inspection firewall. Here comes our old favorite zone diagram, however with some fire on the wall. In Archer, to secure different layers of zone, we implement firewall rules. These rules are also implemented between servers, that is web, app, and database, and between users and reverse proxy, and from reverse proxy to web servers. We open the ports and we provide the rules wherein we have to see that the users who are able to log in and are sending the data is secured and is validated against those firewall rules. Here we will look into what is a SSL certificate, why do websites need SSL certificate, how can we obtain SSL certificate for our website, and how can I tell if my website has SSL or not. SSL stands for Secure Sockets Layer. In simple words and without getting into too many technical details, adding an SSL certificate makes the connection more secure and much safer when you browse, buy, and communicate online. Initially, a secure session is established via handshake, an automated process of negotiation between the server and your browser. Your data is being encrypted in a way that only the intended recipient can understand it. This is all very important because the information being sent through the web is being passed on to different servers. All your data would be very easy to steal, like password, credit card numbers, etc. if it is not encrypted with an SSL certificate. You might think that your site is relatively small and no one would want to attack it, and you would be wrong. Every website on the internet is a potential target for hacker. Additionally, most web attacks lately are being made by bots and not real human. A web crawler will search for known vulnerabilities, and if one is found, it will attack it. All this happens behind the scenes, and the user experience is not being harmed in any way. An SSL certificate is hosted in website's origin server. SSL certificate makes SSL TLS encryption possible, and they contain the website's public key and the website's identity along with related information. Now let's look into the other aspect. Have you ever noticed that some URL starts with HTTP while the other starts with HTTPS? Maybe you noticed that extra S when you were browsing websites that require giving over sensitive information, like when you were paying bills online. But where did that extra S comes from, and what does it mean? To put it simply, the extra S means your connection to that website is secure and encrypted. Any data you enter is safely shared with that website. The technology that powers that little s is called SSL. SSL certificates are what enables website to move from HTTP to HTTPS, which is more secure. From an SSL certificate to be valid, domains needs to obtain it from a certificate authority. A certificate authority is an outside organization, a trusted third party that generates and gives out SSL. The certificate authority will also digitally sign the certificate with their own private key, allowing client devices to verify it. Most, but not all, certificate authorities will charge a fee for issuing an SSL certificate. Once a certificate is issued, it needs to be installed and activated on the website's origin server. Now the question comes, how can I tell if my website has SSL? The URL says HTTPS and not HTTP. It means your website is secure. Second is, you will see a padlock icon in the URL bar. You can click on the padlock to read more information about the website and the company that provides the certificate. Even if a website has the HTTPS and a padlock, the certificate could be still expired, meaning your connection wouldn't be secure. In most cases, a site that displays as HTTPS will be secure, but if you encounter a site that asks for a lot of personal information, it may be worth double checking to be sure the certificate is valid. I am sure this has become now your favorite diagram too. And of course, now with the addition of SSL certificate on Archer servers. As you can see, SSL certificate is bind with reverse proxy as well as web server. User connects with web proxy and validation takes place and details are encrypted and sent to web server which has SSL certificate. This is a single SSL certificate installed on both reverse proxy and web server.
As true pioneers of GRC software, Archer remains solely dedicated to helping customers understand risk holistically by engaging stakeholders, leveraging a modern platform that spans key domains of risk, and supports analysis driven by both business and IT impacts. But if your organization solely relies on RSA to provide a built-in cybersecurity to protect your data within your Archer use cases, this is a mistake. Every organization needs to implement basic cyber hygiene practices. It doesn't matter whether you have 10 or 10,000 employees accessing Archer. The world is becoming increasingly connected, and the size and impact of data breaches is on the rise. Next, let's look at ways to create a cyber hygiene routine that can prevent cyber criminals from causing security breaches, installing different types of malwares, and stealing sensitive information from your Archer platform. Fraudsters frequently use social engineering attacks to trick unsuspecting employees or individuals into divulging sensitive data that they can then use to gain access to protected systems. RSA recommends that you use the following guidelines to help reduce the likelihood of a successful social engineering attack. If helpdesk administrator need to initiate contact with the user, they should not request any user information. Instead, users should be instructed to call the help desk back at a well-known help desk phone number to ensure that the original request is legitimate. Help desk administrators should only ask for username of the user over the phone when they call the help desk. Help desk administrators should never ask for user passwords. Help desk administrators should authenticate the user's identity before performing any administrative action on a user's behalf. RSA recommends that you instruct your users to do the following. Never give their passwords to anyone, not even to help desk administrators. Change their passwords at regular intervals. Be aware of what information requests to expect from help desk administrators. Always log off from the RSA Archer web interface when finished. Always lock their desktops when they step away from their computers. Regularly close their browser and clear their cache of data. Do not upload any files to RSA Archer from sources other than themselves. Never enable active content when opening CSV files with spreadsheet applications like Microsoft Excel. Note that RSA recommends that you conduct regular trainings to communicate this guidance to users. Archer uses a folder on the file system for storing files. The default location is C:\Archer Files repository. RSA recommends that you define the location of the repository folder to be a share that uses a UNC path outside of any web and services server. Doing so eliminates the possibility of denial of service attacks and large file creations. Note that if you plan to use any data encryption, the file repository and Windows certificate store must be located on separate machines. RSA recommends that you restrict permissions on the repository folder to read, write, and modify for the account that the IIS processes are running as and for the account that the job engine service is running as. Once again, coming back to our friend SSL. Due to the issues presented in SSL 2.0, the protocol is deemed unsafe to use and should be completely disabled. Similarly, the POODLE, padding Oracle on downgraded legacy encryption vulnerability, causes SSL 3.0 to be unsafe for use and should be disabled. Unless there is a need to support legacy browsers, even TLS 1.0 and 1.1 should also be disabled. Patches are released on an as-needed basis. All security patches for RSA Archer originate at RSA and are available for download as an update as long as you have a current maintenance agreement in place with RSA. Updates are available from RSA Secure Care Online. Note, it is recommended to run the latest security patches for any softwares that you run using with RSA Archer from the qualified and supported environments. As with any critical infrastructure component, RSA recommends that you constantly monitor your system and perform periodic and random audits. For example, audits on configurations, permissions, and security logs. Ensure that the configurations and user access settings match your company's policies and needs. The list is really exhaustive and not possible to cover in a 45-minute presentation. In fact, maybe a one-day presentation won't be enough to cover all the points. But thankfully, a lot of the above and many, many more you'll find in Platform Security Considerations Guide from RSA and also from your IT security practitioners. Also, another important aspect of cyber hygiene is that it can help your Archer platform hardware and software to run at peak efficiency. Without maintenance, files can become fragmented and programs can become outdated. For example, patching can not only reduce the risk of exploitable vulnerabilities, it can also introduce new or improved existing functionality. Routine hygiene is beneficial for maintenance and security of your computers and software, especially during times when your users are forced to work from home. Being more cyber aware and practicing healthy cyber hygiene is what will ultimately help you and your businesses using Archer when they need it the most. When taking a layered security approach, always start by simplifying. To quickly summarize, we looked at the Archer architecture, its components, supporting infrastructure, and where it's vulnerable to attack inside your individual organization's network. We started at the client layer. It is where the user interaction happens. The TLS layer provides confidentiality, verifies apps, and ensures attackers can't tamper with the data in your Archer use cases while it's in transit. The DNS layer translates the domain names and IP addresses. The services layer is where the code runs and data processing occurs. In the access layer, we talked of how to define and set up authentication and authorization for users, external applications and APIs. And finally, the network layer is the infrastructure where all of this happens.
If your Archer platform's IT infrastructure is flexible, reliable, and secure, it can help your organization meet its goals and provide a competitive edge in the market. Alternatively, if your IT infrastructure isn't properly implemented, your business units can face connectivity, productivity, and security issues like system disruptions and breaches. Overall, having a properly implemented Archer infrastructure can be a factor in whether your organization can maximize its ROI on Archer. By implementing a layered security infrastructure, you can provide a positive customer experience by providing uninterrupted access to your Archer website. You can develop and launch Archer solutions and use cases to market with speed. Collect data in real time to make quick decisions. And improve employee productivity. So this brings us to the end of our presentation, and we thank you once again for attending. Hope you enjoyed the presentation as well as it was informative for you. So until next time, take care Be well and goodbye.
Thank you, everyone, and take care, keep safe. Bye.